Have you ever wondered what actually happens inside the metal shell of your laptop the moment you click a button? It feels instantaneous, but there is a hidden marathon taking place behind the glass. Welcome to ITSU 1001. Think about the shop you just entered. You have the grinder, the espresso machine, the barista, and the beans. None of these do much on their own, but they are all linked together to serve you a drink. When we see a team of parts working as a single unit like this, we call it a system. Formally, it's a collection of components organized so we recognize them as one entity. A computer works on this exact same logic. Standard users come here for the end result, the coffee. But as an IT student, you are learning to manage the logistics of the entire shop. Understanding technology means seeing past the screen and recognizing the highly organized team of parts working together to get the job done. To keep the cafe and the computer running, they both follow a basic three-step pattern: input, process, and output, or the IPO model. Looking at this diagram, we start with input, like a customer's order or keyboard clicks. Next is process, the barista brewing or the CPU executing programs. Then output, receiving your drink or a monitor displaying text. Above is storage, holding data until needed. Whether you are sending a text or playing a video game, every digital action is just this exact cycle repeating at lightning speed. Making that cycle work requires 4 distinct parts of the system to talk to each other. First is hardware. These are the physical tools, the espresso machines and registers. These equipment processes the data and handles the inputs and outputs. Second is software. This is the barista's recipe book. These are the specific instructions that tell the hardware what to do and what order to do it in. Third is data. These are the raw ingredients, like the unroasted beans. Data is the set of facts and observations the system is processing. Fourth is communications. This is the delivery network that shares beans and recipes between this cafe and other branches across the country. Connecting these individual systems creates a network. In this diagram, you can see how different departments, like sales or finance, all link back to central servers. This allows isolated parts of a business to work as one massive infrastructure. Now, imagine if our cafe decided to stop baking its own bread and instead used a massive off-site mega kitchen. That is cloud computing. It's a shared pool of resources you access on demand. Instead of building your own kitchen, you rent a prep station, a professional oven, or even a finished pastry exactly when you need it. While hardware and data build the individual machine, communication and the cloud allow that machine to link with millions of others and expand its power whenever it's needed. So why do you need to know this architecture instead of just using the computer? Users only need to know a system's basic limits. But as a programmer, you need this knowledge to write efficient software recipes for specific tasks. Systems administrators go even deeper, maintaining the hardware and espresso machines to make sure the shop stays efficient and secure for everyone. Web services designers also rely on this. Look at how this communication loop moves from the user's page request to the server's response. Designers select the data formats and languages that make this loop as fast as possible for the customer. Studying IT turns you into the architect who designs the global franchise. A computer is never magic. It is a team of parts waiting for your instructions. To prepare for our next lesson, read Chapter 1 of your textbook. I'll see you then.